Hey guys, today I'm going to be talking about the HX addition in Organic Chemistry 1. So basically, to start off, I'm going to explain the Markonikov position and the anti-Markonikov position. So the Markonikov position is the more substituted carbon position, and this is usually where your halogen goes. So it's the more substituted carbon. So the anti-Markonikov, which will only occur when there's HBr and peroxide, is the less substituted carbon. So your bromine or bromide ion will go on the less substituted carbon. So less substituted carbon. So if we look at this example here, we have the, hold on, let me do this on the right side. So I draw this out. You'll have the more substituted carbon on the left and the less substituted carbon on the right. Now, because there's no peroxide in this case, we're going to be using the Markonikov addition. So your your Br will go in this position right here, and your H will go on the less substituted carbon. Now, down here, I have some examples. I also have an example with peroxide, which will be the anti-Markonikov position. First, let's start with the HCl example right here. Also, normally in HX addition, your X is usually a halogen such as Br, Cl, I. I don't think it's normally F, so yeah, those three are the most common halogens. So example A, we don't have a peroxide and it's not bromide, so we're not going to be doing anti-Markonikov. Usually you just want to stick to Markonikov if there's no peroxide or bromide. So we have the less substituted carbon here and the more substituted carbon here. That means our H will be going here and our Cl will go here. So when we break that double bond, our Cl will go there and our H will attach here. Now you don't have to show the H, I'm just showing it there for clarification, but it would look like this, your final product. Now in this example, it's HBr, no peroxide, so we're doing the Markonikov. And so we have the less substituted here. So our H will go there. And here we have the more substituted, so our Br will go here. So our final product will look something like this. Br will attach here, and our H will attach here. And once again, you don't have to show the H, but I'm just showing it for clarification. Down here in this example, we're doing an HCl addition. So our double bond here, we're gonna put the H here because that's the less substituted spot, and our Cl will go here. However, in cases like this, so in HX addition, a carbocation intermediate is formed when you're doing the Markonikov, and so the carbocation is subject to rearrangement if it can move to a more stable position. So in this case, let me show the first step here. So our H would attach here, but because we didn't attach anything to this spot right here, we're going to have a carbocation. Now this carbocation is on a secondary carbon, and we can make it more stable by moving it to a tertiary carbon. In this case, how can we do that? If we look at this, we can do a methyl shift. So we have a quaternary carbon here. But if we do a methyl shift, we can move the carbocation to a tertiary. So if we do the methyl shift, right, it's gonna look something like this. So your methyl will go there, and then your carbocation will go here. So that's a methyl shift, and now our carbocation is on a tertiary position, which is very stable. And now, once we add the Cl, this was the intermediate that was formed, these two. Our final product will look something like this. That would be our final product. Let me just actually draw this a little bit closer to the screen on the left. All right. So we're gonna have the carbocation rearranged there, and our H is attached here, and then when we do the final reaction, we're going to get your Cl attached there. And yeah, that would be your final product. And you don't have to show the H. I was just showing it for clarification. And this is in this last example, we have HBr with a peroxide. So this right here is your peroxide. It's usually 2 O's attached to 2 R's. That's your peroxide. So when you have peroxide and HBr, it's going to be an anti-markonikov addition. So we have the less substituted carbon here, and then more substituted carbon here. Anti-markonikov means we're going to be putting the bromide ion on the less substituted spot. And in this case, there's no rearrangement because a radical is formed. So this would be our product. So our Br is going to attach to the anti-markonikov position. And at the more substituted carbon, our H is going to attach. So this would be our final product. And you only do anti-markonikov whenever you have a peroxide and bromide. Keep that in mind. All right, thanks for watching.